Hello all, welcome to Code Hub. Today let us solve the LeetCode daily challenge. And the problem is remove end node from the end of the list. Given the head of the linked list, remove end node from the end of the list and return its head. So we have given a linked list and an end. We have to return the node which is from the end of the. We have to delete the node from the end of the list. N is 2, then the no, yeah, from the end the 4 is the second node from the list and we have to delete it. And if the n is 4, from the end the fourth node is 2, so we have to delete that node. So what we can do is, uh, first we can have two pointers, where one pointer is first pointer first pointer will be at head, and we can move that first pointer till n number of times. Let me consider 1 2 3 4 5, and let the first pointers be at head. First we can traverse n two times, 1 2, and now we can also have a second pointer. Now we can have a second pointer. Now we will move the both first and second pointer simultaneously, one move at a time. So first will move once and second will be moving once, and this first again will move once and the second will move once. And whenever you see first of next is null, we break out, we break from the loop, and you can see that this second pointer stands just before the pointer, just before the node, that is the nth node from the end of the list, and you can just delete it. The second of next is nothing but this second of next. So we can just delete this particular node 4 like this, using this first and second pointers. So that's the approach we are going to do now. There may be edge cases. We may first try to code this. So we need two pointers. First is equal to head, and star second is equal to head, and first we have to move n number of times. We have to move the first pointer n number of times. So while n minus minus first equal to first of next, n will be always, the size of the node will be 30, and the number of nodes in the list is sz. So n will be always less than or equal to sz. So n is always less than the number of nodes present in the linked list. So we can consider several cases as well. 1 2 3 4 5. What if n is equal to 5? If n is equal to 5, so the first pointer will be here, and whenever this loop executes, the first will be executed 1 2 3 4 5, and you can see that as you can see that the first pointer reaches the null whenever n is equal to the size of the node. Whenever n equal to the size of the node, size of the linked list, we have to delete this head node. So the first pointer will be at null. So if first is null, if my first is null, we can just what we can do is we can just change the head and return the head equal to head of next and return head. We can just do it, or else we can just do like this, return head of next. It is more easier, because the fifth node from the end of the linked list is 1, so we have to delete this 1. So the new head will be 2 3 4 5, and the linked list will be 2 3 4 5. If this is not the case, then the first pointer will be at somewhere inside the linked list, and then we can do the previous approach itself. While my first of next is present, then first equal to first of next and second equal to second of next. It is simple. Let us take another example. If what is n is equal to 4. If n is equal to 4, n would have been reached here. 1, 2, 3, 4. And this is our f would have been reached here, and this case will not be executed, and this case also will not be executed, and the first pointer will be here and second pointer will be here, and we have to delete this particular node. Sorry, we have to delete this particular node too. So what we should do, second of next is nothing but second of next, correct? We have to delete this particular node too. So one of next is nothing but one of next, so that this 2 will get deleted and this one's next will be pointed to this 3. That's what I'm meaning here. Now let us handle for another case. What if n is equal to 1? We have to delete this node 5. So in first iteration we would have been moved this first pointer here, and then we will be not executing this case, and then we will be executing this case. This while loop will be going. First of next is present, so we will be moving the simultaneously first and second. Again first of next is present, we will be moving simultaneously. Again first of next is present, we will be moving simultaneously. And you can see that the first now the first of next is not present, so we will be coming out of this loop, and the second of next is nothing but second of next second of next is null. So obviously here in this case also it is satisfying our condition, so we can just finally return this head. And let us try to run the code and see. I have explained all the cases. Let us try to handle every case and see. 5, 1. Superb, it gets accepted for all the cases. Now let us submit our code. So the time complexity here will be order of n. It got accepted. Superb, we have handled all the cases, so it got accepted. Hope you like the solution. Let me know in the comments if there are any suggestions, and let us see in tomorrow's LeetCode daily challenge. Until then, bye.